Problem number 2 for our IR. So once again, just a disclaimer, I did not make this problem. I found it online, so I don't know what the answer is, but we're going to walk through my process. So as always, I'm going to draw that line at 1500. Then I'm going to go to 2000. So that's going to be my SP2 region. Then I'm going to go to 2500. That's going to be my SP. And then everything else is just my hydrogen region. All right, so I know a lot of you guys have been emailing me, asking me, how do I know if a peak is significant? Okay, we just kind of get a feel for it. I know you guys don't like that answer, but it's really just a practice thing. So some of you guys might be jumping at this and like, oh, it's a peak. I'm very hesitant to believe that that would be a peak. I would be very suspicious of that one. But that's not where my eye's going to jump to. Where I'm going to look at is this right here. There is no doubt in my mind that that is a peak that I should be paying attention to. And it just so happens to fall in my SP region, which tells me that I should have a triple bond in my structure. So that's going to get rid of A really fast. And then everything else has a triple bond, but I could also get rid of B because, again, I don't have a nice, very broad peak that tells me I would have an alcohol present. So what is left is C through E. Now I'm going to be looking at those structures, and what I notice is that I have some terminal hydrogens, or I have alkyne hydrogens. Well, that should be pretty noticeable in my IR. So in the previous video, we talked about that idea at 3000, if it's below it, these are going to be hydrogens that are bonded to an sp3 hybridized carbon. Well, C, D, and E have all of those. So that's not going to eliminate anything. If it is slightly above 3000, that would tell me if I would have sp2 carbon hydrogens. What I mean by that is I would have a hydrogen bonded to an sp2 hybridized carbon. I don't really see anything here, so I'm going to go ahead and eliminate D because this does have sp2 hybridized carbons, and I don't see any stretches there for that. So I'm going to go ahead and get rid of that one. And then I have this peak right here. So 1, 2, it's about 3,300. That is where I would expect to see a hydrogen bonded to an sp hybridized carbon. So I'm going to say that the answer here is going to be E because I see that peak. Now, if I did not see that peak, I would be more convinced that the answer would be C. But just because I have that stretch right there, or I have that peak around 3,300, to me, that seems like it's going to be the hydrogen at the end, or on a terminal alkyne, or a hydrogen that's at the end of a triple bond.